The Pythagorean Theorem. Pythagorean Theorem. Pythagorean Theorem. The Pythagorean Theorem. Pythagorean Theorem. Pythagorean Theorem. Hello everybody, welcome back. In this adventure we're going to study the Pythagorean Theorem. And we might get a little pop-in visit from the man, the myth, the legend himself, Pythagoras. So buckle up and enjoy your experience.
I am the great and powerful Pythagoras.
You sound like the Wizard of Oz with that kind of talk.
Nonsense! I have returned from the planet Euclid with a special message. A tip that will help you all.
Ooh, he's going to tell us the Pythagorean Theorem.
Stop interrupting me. My special message is don't spit into the wind. Spit with the wind. With the wind.
Not what I was expecting.
And Mr. Haugom is awesome. So long.
Well, thanks for nothing, Pythagoras. I guess we'll have to do this on our own.
Hey, you got anything to eat?
No, I'm sorry, I don't.
Okay, bye.
Man, that Pythagoras is one strange dude. So I guess because Pythagoras wouldn't just come out and tell us what his theorem is, I guess we'll have to discover this together on our own. The theorem is involving squares and triangles, so let's look at an interesting relationship with some squares here. This square has a side length of 3 and an area of 9. And if you take any square's area and do the square root of it, it will always tell you the side length. Square root of 9 is 3. The area is 9, the side length is 3. Here's another square, and its area is 16. And square rooting the area of 16 gives us the side length of 4, a 4 by 4 square. The first two examples are called perfect squares because when you take the square root of their areas, you get whole numbers. This example is considered a non-perfect square because the square root of this would not be a whole number. The side length would be some sort of decimal. We can see that this is a square because it does have 4 equal sides, and all of these are 90-degree angles, but it's a little bit more difficult to measure the side length because it does not line up with the rows or columns of dots. It's going diagonally through. But we could still find its side length by knowing its area. This has an area of 4 so far. These little triangle pieces are triangle halves of squares. So this would make a 5th. These together would make a 6th square. These together would make a 7th. And these together would make 8 full squares on the inside of our purple square. So again, if we know the area, we can always take the square root of that area and it will tell us our side length. This works out to be about 2.83. Pythagoras, get out of here! Side lengths and areas of squares go hand in hand. Here is a 10 by 10 square. And 10 times 10 tells us the area is 100. And if I knew that the area was 100 of the square, all I'd have to do is take the square root, and it tells me the side length. It's 10 by 10. This square is 20 by 20, and 20 times 20 tells us that our area is 400. And if I were to square root the area of the square, it would tell me the side length, a 20 by 20 square. Now I have a square here where I don't have boxes on the inside, so I can't just quickly count the area. So let's just pick an area in between 100 and 400. Let's just pretend that the area of this square is 300. Well, I don't know what the side length of this square would be, and this definitely is not a perfect square number, but I know how I could find the side length of this square if I needed to. That's right, all I have to do is square root its area. And this works out to be about 17.32. So large areas have larger sides, smaller areas have smaller sides, and because this area is in between 100 and 400, it makes sense that its side length should be between the 20 and the 10.
So I found this new hat. Howdy, partner.
Buzz off, Pythagoras. So that takes care of the square part of this lesson. Now we need to talk about the right triangles that are involved with the Pythagorean theorem. What in the world?
Hey, what are you guys doing?
Don't you have something better to do?
Maybe?
Oh, that Pythagoras is driving me crazy. Anyways, getting back to these triangles, the right triangle is very important in the Pythagorean theorem. It's all based off of that. So some terminology that you need to understand are the two small sides that make up the right angle are called the legs. And they're usually described as A and B. The longest side in a right triangle is always called C, the hypotenuse. So Pythagoras,
Yes?
I was talking about you, not to you.
Okay, bye.
As I was saying, Pythagoras found a special relationship related to right triangles and the squares on the three sides of these right triangles. Every single right triangle, no matter what size or shape, as long as it had a right angle, every right triangle had a special relationship with those three squares. Let's take a look at this triangle with legs of 3 and 4 and has a hypotenuse of 5.
Oh, what's that thingy?
The shape?
Yeah.
It's a triangle. I thought you knew all about them.
Oh, okay, bye.
When we build squares around the sides of the right triangle, a relationship is found. This leg square plus this leg square, when you put them together, is the same area as the hypotenuse square. 9 plus 16 does equal 25.
Hey, I found something to eat. It's an apple.
Yeah, I think we can tell.
Okay, bye.
Here's another example. This leg square is 5 by 5 and has an area of 25. This leg square is 12 by 12 and has an area of 144. The hypotenuse square is 13 by 13, and that multiplies to make 169. And again, our relationship, leg square plus leg square equals hypotenuse square. 25 plus 144 does equal 169. So what does this all tell us? What is Pythagoras' theorem? The Pythagorean theorem is... There it is. A squared plus B squared equals C squared. This represents a leg square, this represents a leg square, and this represents the hypotenuse square. Add the two little squares together, it will add to make the big hypotenuse square. So let's see how this diagram and how the actual equation work hand in hand. So there we have a squared plus b squared equals c squared. Here are our side lengths. A is 3, B is 4, and C is 5. If you look up here on the diagram, Let's swap out the actual letters for the actual numbers now. And simplify. 9 plus 16 does equal 25. So it works with the equation, and you can see that it does in fact work with the diagram. 9 plus 16 is 25.
Hey, look what I just learned how to do.
Let's try this out. Let's say you were asked to find the length of the hypotenuse here. If side A was 10 and side B is 24, how long would side C be? To figure this out, we could think about the diagram. When we have a 10 by 10 square on this leg, we would get an area of 100. The area of this square would be 24 by 24, or 576. So that tells me that the hypotenuse square would be a total of 676. And to find the side length of any square, all we have to do is take the square root of its area. We just found that the square root of 676 would be 26. The length of our hypotenuse is 26 units long. But most people don't want to be drawing diagrams. They'd rather be working with a formula. So we can use the Pythagorean Theorem. Our A is a 10. Our side B is 24. And our side C would be unknown. If we simplify this out, 10 squared is 100, which represents the area of one of the leg squares. 24 squared is 576, the area of the other leg square, and together they combine to make the C squared, the area of the hypotenuse square. So the area of the hypotenuse square is 676. But again, I'm not looking for the area of the hypotenuse square. I want to know what the side length of that would be, because that would be the hypotenuse of our triangle here. So our last step would be to square root that area. When we're working with the formula down here, the algebraic steps here to finish this off, to undo this exponent of 2, is again to square root. We square root both sides. That would cancel out our exponent. We're left with side C. The square root of 676 would be 26. So we have just solved that our hypotenuse would be 26 units long. Pythagoras, is that you?
I tricked you. Knock, knock.
Who's there?
Me. Gotcha. Bye.
I don't think you understand how knock-knock jokes work, Pythagoras. Let's try one here where we're trying to find a leg. So let's say that side A was 6, B was unknown, and we knew the hypotenuse length is 10. So we need to remember that the hypotenuse is the longest side. 10 will be the longest side in this triangle. So the area of this hypotenuse square, 10 times 10, would be 100. And the area of the leg square on side A would be 36, 6 times 6. So remember, it's the two leg squares that combine to add to make the hypotenuse square. So 36 plus something is 100. Quick subtraction tells me that this is going to be 64. But again, it's not the areas of the squares that I'm after. I want to know the side length of the square. The square root of 64 would be 8. I now know that leg B has a length of 8. And this is how this would look solving it with the Formula: a squared plus b squared equals c squared. So we now have our letters plugged in. Our a is a 6, our b is unknown, and our c is 10. We've simplified 6 squared and 10 squared. So the only difference now is that we're trying to figure out what the letter b is, so we have to do subtraction instead of addition next. So when using the algebraic method steps, you can see that we're subtracting 36 on both sides. That will leave us with b squared on the left and 64 on the right. And I don't want b squared, I want to know what side b is, so the way to eliminate that exponent of 2 is to do the square root. b equals 8.
Don't worry, I'm okay.
So what good is this? I mean, we're not going to really be drawing triangles and squares just for the fun of it. Where does this apply in real life? Well, let's just say that you were a treasure hunter and your ship landed on an island and you found a treasure. You then headed north to find shade underneath this lovely palm tree, but then you wanted to head back to your ship. How can the Pythagorean theorem apply here? Well, the ship's location in relationship to the treasure, and then the treasure heading north to the palm tree, this forms a right angle. And then the palm tree back to the ship is the hypotenuse of a right triangle. We've just made a right triangle. So anytime you have points or locations that form a right triangle, you can use the Pythagorean theorem to answer questions about that. So if the ship's distance to the treasure is 24 miles, and the treasure to the palm tree is 32 miles, how far would we have to walk back from the palm tree to our ship? Well, we first need to start assigning what is going to be A, what is going to be B, and C. Let's call this leg A, this leg B, and the hypotenuse is always side C. And now we can start filling in our A and B and start to work out what side C would be. Now that we've simplified our a squared and b squared, we know that c squared would be 1600. Again, I don't want c squared, I want just regular old c. And the square root of 1600 would be 40. The length of our hypotenuse here would be 40 miles. 40 miles from the palm tree to the ship. We better get hiking, because here come those pirates.
Matey, you wanna walk the plank? So did you find it?
Find what?
The treasure.
That was just an example, Pythagoras.
Oh, okay. Those pirates sure sounded scary, though. Bye.
Here are some more real-world applications of the Pythagorean theorem. Hopefully you now have a better understanding of how and why the Pythagorean theorem might be used. Sorry Pythagoras couldn't tell us this information. Well, maybe we should get out of here before he comes back one last time. What is it that you want now, Pythagoras?
That's not my name.
Okay, then what is your name?
Call me DJ Pythaggy.
I'm not calling you that.
Do it.
No!
I said do it.
Okay, DJ Pythaggy. What is it that you want?
Nothing. I just want to hear you say it. You math teachers are so dumb.
The Pythagorean Theorem! Pythagorean Theorem! Pythagorean Theorem!
Oh, I'm so sorry to interrupt.
Really? I don't think you are.
There's one other thing I need to tell you.
What's that?
Remember when I said I had a super important message?
Yeah?
Well, I forgot to tell you that a squared plus b squared equals c squared.
Really, Pythagoras? That would have been useful information about 20 minutes ago.
So long. Bye. Oh yeah, and that apple, it is super delicious. I think I'm gonna have another one.
Oh, that Pythagoras drives me crazy.